we want to state the limit definition of the derivative of f at x. So f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. We're going to use this limit definition of the derivative to show that this derivative is the derivative of f of x equal 1 over x minus 5. So f prime of x is going to equal the limit as h goes to 0. We need f of x plus h, so that'll be 1 over x plus h minus 5 minus f of x, that'll be 1 over x minus 5, and that's all over h. Now if we tried to directly evaluate this, we'd be dividing by 0, so we can see we're going to need to do some kind of algebraic manipulation, and seeing two fractions there leads me to think let's try and get a common denominator and see what happens. So this needs an x minus 5, and this second fraction needs an x plus 5 minus 5 to get a common denominator, but whatever we do the bottom, we got to do the top. So we need to put, I'll just write it over here, x minus 5, and this one needs an x plus h minus 5. Okay, so now we have the limit as h goes to 0 of x minus 5, and this negative applies to all three terms here, so that will make that negative x minus h plus 5, and that's over our common denominator, which was x plus h minus 5 times x minus 5, and then that whole thing is over h. Let's see what we can do to simplify. X and a minus x, minus 5 plus 5. And the other thing I can do is this is h over 1, so I can flip it over and multiply it 1 over h. So let's write down what we now have. We have the limit as h goes to 0 of negative h over x plus h minus 5 times x minus 5, and then the times the 1 over h. The h will cancel with this h, and also our limit, we can let h go to 0, so the h part is 0. So what we have left is negative 1 on the top and x minus 5 and x minus 5 on the bottom, which we of course could write as negative 1 over x minus 5 squared. So we have shown that indeed this is the derivative.